So here we're trying to find the solutions of this radical equation, and we're also trying to see if there's any extraneous solutions. And so what are extraneous solutions? Well, let's first look at the solutions, and then we're going to see what an extraneous solution may mean. So what do we begin with? What do we do here? Well, we know that we have a radical here, and we have a radical on this side as well. So somehow we have to figure out how to get rid of radicals. So what does the rule say? I'm going to put my scratch work over here, and everybody should be taking notes. So how do we get rid of radicals? If I have a square root of x, then I can get rid of this square root of x if I raise it by the index, which is 2. So square root of x squared gives me x. I got rid of the radical. If I have cube root of x, I need to raise it by the index. Where's my index? My index is 3. Cube root of x raised to 3 gives me x. I got rid of the radical. So here I have square root of x plus 21. My index is 2. So I'm going to have to raise both sides by the index, and the index is 2. Yes, very good. So I'm going to rewrite my question, because I love to rewrite questions. And then I'm going to say, okay, well, if I take both sides and I start squaring them, that may help me. I'm going to square both sides. But when I square this side, I don't just have the square root of x, I also have 3 minus when I square both sides. So what happens? Well, this square cancels out this radical. The square doesn't cancel out this radical because I have 3 minus something. Alright, so this side was easy. I got x plus 21 equals. But on this side, the square doesn't automatically cancel this radical out because it's not by itself. I have something else here. Mr. Wilson, can you make sure that everybody's taking notes? I don't think the person sitting in the back, they're taking notes. So here, the square means that I get to multiply 3 minus square root of x times 3 minus square root of x. Because that's what square means, right? Multiply twice. So that's what we're doing. So what do we get? We get x plus 21 equals 3 times 3, which is 9. 3 times minus square root of x, which is minus 3 square root of x. Minus square root of x times 3, which is minus 3 square root of x. And minus square root of x times minus square root of x, which is plus square root of x squared, because you're multiplying it twice. Now, does this square cancel out this square root? Yes, it does, because this is by itself. You're just raising the square root to a square, so this does cancel out. Alright, so let's keep working. What do we have? We have x plus 21 on this side. We have 9 minus 3, which gives me minus 6 times square root of x plus x, because here the square root went away. Alright, let's combine some terms. I can move this x on this side, or I can move this x on this side. I'll move this one over here. So I'll say minus x minus x. This cancels it out. Let's cancel this out as well. Alright, well, that's good. I'm eliminating terms. That's always good. So now I have plus 21 equals 9 minus 6 times square root of x. Well, I can actually move this 9 out as well on this side by subtracting. So this 9 goes away. So 21 minus 9 is 3. So I get 3 equals 6 times square root of x. Alright, well, sorry, what did you say? Oh, 21 minus 9 is not 3. Yeah, 21 minus 9 is what? What is 21 minus 9? 12? Okay, 12. Very good. Thank you. 12. Okay, so I have 12 over here. I can divide both sides by 6. And so that gives me a 2. Very good. So it turns out that 2 equals square root of x. Now, how do I get rid of this? Square root of x. Well, I can raise both sides by 2 again. And so that means that 4 is equals to x. So I solved it. Now let's do a check. To do the check, I'm going to rewrite my problem. X plus 21 equals 3 minus square root of x. I'm going to replace x with 4. So I get 4 plus 21 equals 3 minus square root of 4. 4 plus 21 is 25. So I get square root of 25 equals 3 minus square root of 4, which is 2. Square root of 25 is 5. 3 minus 2 is 1. Does 5 equals 1? No. So either this is wrong or this is wrong. Neither one of them is wrong. Sometimes we get a solution when we're doing radicals which does not make sense. And that's perfectly normal. That's what's called an extraneous solution. That's why it's very important to check our work. Very, very important to make sure that we are checking our work and checking the answer